How do the thermodynamics of an Eavor loop work? Unlike other types of geothermal, the Eavor loop uses conduction instead of convection to retrieve heat from below the Earth's surface. With conduction, heat transfer takes place between mediums by direct contact. In convection, the heat transfer takes place within a liquid or gas that's in transit. For example, with conduction, heat transfers into your hands as you hold a hot cup of coffee. With convection, heat moves in hot air next to a heat source to another part of the room. In an Eavor loop, our wells are in direct contact with hot rock, so as cold fluid moves through the system, that direct contact transfers heat from the hot rock to the fluid constantly via conduction as it makes its way through the system. To represent how we use conduction in our wells to pull heat from the rock, we must imagine a cross-section of a wellbore through the rock. We will now digitize this cross-section to highlight what happens in each section of rock. Throughout the system, the rock has a higher temperature than the circulating liquid, causing heat to transfer from the rock to the liquid via conduction. The rock also has a much higher thermal mass than the circulating liquid, meaning that a 1 degree temperature gain in the fluid corresponds to a much smaller drop in average rock temperature. As the conduction process takes place, the fluid moves from section to section where the same process happens again. Except as it moves, the fluid is hotter as it reaches the next section, so less and less heat is pulled from the rock as the fluid progresses through the system. It is true that this process removes heat from the surrounding rock as the fluid flows through the system. However, that heat is constantly replenished from the outer layers of rock. The same process between the rock and fluid occurs between the inner and outer layers of rock. The rock heats up the rock, which heats the fluid. Overall, the heat is constantly replenished by the heat in the surrounding rock, and while the Eavor loop does pull heat faster than it's replenished, the heat production rate of the Eavor loop remains nearly constant for over 30 years. A predictable gradient pattern emerges as the fluid flows through the well system. In an Eavor loop, you will notice wells run parallel to each other. In this situation, the wells are drilled far enough apart so as to not significantly affect the heat draw of each well for a specified amount of time. This is called avoiding thermal interaction. In this graph, we can see the modeling of a single well's heat production over time. Then, with the addition of another well, the production will follow the original line exactly until the wells begin to thermally interact. From this point, you will see the heat production is only slightly less. If we view two wells side by side, you can see the heat extraction profile at each well and how the heat is drawn from the surrounding rock. However, in an Eavor loop, the fluid on the lower well is actually the return well of the system, and therefore the flow direction is reversed, meaning the heat extraction profile is also reversed. This means the pull of heat from each well is even less affected by the other well. This formula allows us to calculate the amount of heat or the thermal energy available in the rock. The large scale of the Eavor loop allows it to access a massive amount of heat, enough to support continuous production at economic rates for over 30 years. Eavor's engineers use formulas like this to determine how much heat and at what rate we can produce from a given Eavor loop. We then consider the value of that energy in the marketplace where the Eavor loop resides and compare that with the cost of building the Eavor loop to determine the overall economic return. Our Earth is an almost endless source of renewable heat energy just waiting to be utilized. With Eavor and the Eavor loop, we can use that heat to generate electricity, heat or cool our homes and businesses, and contribute to energy security and independence with a truly renewable, always-on, reliable, scalable energy source. The time is now. Energy forever.